All right, friends. Well, as you can see, we're here today again, and we've got to do something important. So what we're going to do today is nothing new, but rather try and solve simple questions that sometimes, it looks complicated. All right, so let's look at this question. The question says point A, B, and C have coordinates. A, -7, 3, B, 3, 9, and C. Okay, so this is C, 12, -7, -6, such that ABC is a right angle. So the question is asking us that we should show that ABC is a right angle, and after that, we find the distance AC, and hence find the equation of the second passing through point A, B, and C. Oh, so is that the case? Let's have a look at, let's see. So -7 is the biggest negative on the left, and we got negative, okay, so our values here, as you can see, here is a negative x, this is a positive 3, which is x, and a positive 12, which is x. So when we look at the x value, we got 3, let's see, say roughly if this is our line, then we can see maybe 3, 4, no, 3, 6, 9, okay, and 12. Okay, this will be -3, -6, -9, and -12. So it's a -9. Okay, so that's a rough sketch. And when we look at the y values, okay, let's look at the y values. The y values, we got 3 here, we got 9 here, and we got -6. So 3 and 9. Okay, so let's do the intervals similar like that. So we got here 3, 6, 9, and 12. -3, -6, -9, and -12. Okay, so we plot this coordinate according to the way it says. The first value, as we can see, is -7 and a +3 on the y-axis. So -7, so 6, -7 will be somewhere here. So 6, 7, okay, 9. Okay, so let's see if 7 is there roughly, and we have the y value to be 3. So 7, it goes all the way here. Okay, so our sketch is somewhere, this is our first point. Okay, so this is a point A, which is -7, 3. Okay, and the next point is +3 and 9. On the x-axis, 3 and 9. So somewhere here, so +3 and 9, and that is B. Okay, +3 and 9. And the last one, which is x, which is +12 and -6. So +12 here and -6. So friends, this is C, 12 and -6. So now, if we look at this, then we can draw a line around it. So let's see, let's put a line around it. Okay, let's select our color blue. All right, so we go in there, pick a line. So this is the first point from here to here. It's like that to this point. Okay, and our next point, okay, is from C to B. Okay, all right, we'll pick another point, okay, from B to C. So, in the rough sketch, the rough manner, this is not according to scale though, friends, we are able to sketch our lines. Okay. Now the question says we should prove that ABC is a right angle. Oh, ABC it's a right angle. So we should prove that A, B, C is a what? Right angle. Oh, that's cool. For ABC to be right angle, meaning when we look at it, the angle between AB and the BC should be perpendicular. It should be 90 degrees. So roughly, it's supposed to be 90 degrees somewhere here. So what it also means is, if we take the gradient of AB to be M1 and the gradient of BC to M2, when we multiply the gradient, should give us 90 degrees. So that's what it means. Okay, that's what it means. All right. So this is what it all means for us. So command this. Let me squeeze this one down so that we have this. All right. So squeeze it down a bit. Okay. We have everything here so we can have enough space to do our work. Okay, we can drop it back forward. Yeah, good. So that's what we got. So this is the condition. Okay, let's squeeze so we know that we have our diagram. Okay, so we can put a diagram somewhere here. Then we'll continue. Now, okay, so that's what we have. So we need to find the gradient of the line AB. Okay, so let's find the gradient of the line AB. So gradient of the line AB, which will be given as y2 minus y1 over x2 minus x2 minus x1. All right, we know our first coordinate is -7, 3 for A, and the B is 3, 9. All right, friends, so if you look at these two coordinates, we say this one is x1, y1, x2, y2. So all what we got to do is to find the gradient of AB. So what do? So we subtract 9, the y, this is a y, 9 minus y1, there's 3 over here, divided by the x2, which is 3 minus 7. So the top one will give us 6, okay, and the bottom one will be 10, which is equivalent to 3 over 5. So that's the gradient of the line AB. So now let's call for the gradient of the line BC. So the gradient of the line BC, okay, BC, we have the coordinate of B to be 3, 9, and the that of C to be 12, -6. So 12, -6. So we find the gradient of the line, okay, this line over here, BC, okay, so BC, this is what, x1, y1, x2, y2. The same formula, y2 minus y1 over x2 minus x1. Okay, friends? And that we'll be able to substitute our respective values. We know y2 is -6, so minus 9 over x2, which is what, 12, minus 3. And so the top here gives us minus 15. And the bottom will give us 12 minus 3. Yeah? And that will be 9. So this will reduce to be minus 5 over 3. Okay, so now we see we've got gradient for the MAB. Okay, So we have our gradient. So this is a gradient of MAB and our gradient for that MAB. Again, the gradient. Okay, so we have our gradient for MAB and a gradient for MAB. Change this one to red. Okay, so that gives us the gradient. Okay, here is our gradient of MAB. Okay, this is the gradient of MAB and gradient of MBC. So these two gradients, you see, it said we should show that ABC is a right angle. That means when we multiply the gradient MAB, which are denominated by 1, and the other MBC, should give us -1. So let's see what is true. So gradient of MAB, okay, MAB multiplying MBC. So this one, and the first one is 3/5. Multiplying -5/3. And that for sure gives us what? -15/+15. And this implies that gradient of M8 multiplied by gradient of that gives us -1. Hence, the proof. Okay, hence the proof. So this is the condition when you're given something like that to prove. So we have the gradients. Okay, now let's look at the question. The next question. Hence, find the equation. I say find the distance AC. There's the B part. So distance AC. Let's go back to define the distance AC. You see, the distance AC. We know our coordinates of A to be -7, 3. -7, 3. And a gradient of B, gradient of C, the distance, the coordinates of C is given as 12, -6. So 12, -6. So to find the distance AC, we are going to use the formula that says that's okay. This is x1, y1, x2, y2. So we say what x1 minus x2 squared plus y1 minus y2 squared, and the square root of the whole will give us the distance AC. So we just, all we gotta do is just substitute this into the equation. So we have this. So x1 is -7, okay, -12 squared plus y1, which is 3 minus 6 squared, and all with the square root sign on top of it. So guys, you getting it? So all what it means is, you know, we have square of 19 plus square of 9. Okay, so that's what we have, and the square root of that. Okay, so when we do that, square of 19 square of 19, okay, will give us, how do I put it, 19 squared and that will give us 361. Yeah, 361. Okay, let's go back. 361 plus 81. So plus 81. And that will give us square root of 442. Okay, this implies the DAC. Okay, let's see. Square root of 442, and that is 21.023 unit. Okay, so this is a distance AC. If this is the distance AC, okay, now let's see. Because we know, okay, that AB is perpendicular to BC, it means that AC is the diameter. Okay, so that is the strong, point that we got to make sure we remember. So it says since AC is perpendicular to AC, AB and BC. Okay, so that is since AB is perpendicular to BC, where it means AC is the diameter of the circle. Okay, now we know the diameter to be 21.023. Okay, now if that is the case, we know always 2 times the radius is always given as diameter. So when we put this equation into use, we say 2r is equal to 21.023. So our radius of the circle will be this number divided by 2/3. Okay, 2.023 to 2. So this divided by 2 will be the radius of the equation. So this divided by 2. So that will be equivalent to 10.51 unit. So we have the radius to be that. Radius to be 10.51. How do we get the center of the circle? Okay, so now we want to find the center of the circle so that we'll be able to, construct the circle. Because the question says, the last part of the question says, hence find the equation of the circle passing through the point ABC. Okay, so now we're knowing that AC is the diameter. Okay, so AC is diameter. Okay, AC is a diameter. So meaning we have to find, since AC is the diameter, we need to find the midpoint of the circle, and that will be the center of the circle. So we know the values for A and C, the coordinate of A, which we saw earlier, as -7.3, and the coordinate of C, which we saw earlier, was 12, negative 6. 12, negative 6. For sure. So this is the coordinates. So once again, we know this one is x1, and this one is x2. This is x, y1, sorry, let me clean this. Okay, so we have this and that. So we say x1, y1, x2, y2. How do you find the midpoint of the circle? So we say the midpoint, the first value of x plus the second value of x divided by 2. And that y, the first value of y plus y, second value of y divided by 2. So this is just elementary. So our x will be negative 7 plus 12 over 2. And the y will be the first y, 3 plus minus 6 divided by 2. So you see, so this, negative 7 plus 12. Yeah, somebody help me, maybe my math is not good. So negative 7 plus 12. That gives me 5. So this is 5 over 2 for the x value. And this, over here, 3 plus minus, that's a negative 3 over 2. So hence, therefore, the center, C, is giving us 5, 2, negative 3 over 2, and our radius, which we know it to be 10.51. So how do you get a circle? How do you define a circle? As the question is asking us. So we know that a circle, the equation of the circle will be x minus a squared plus y minus b squared is equal to r squared. So all what we have to do is to do substitution. Okay, so we substitute this value here in place of a and this value here in place of b, and we'll put a radius into this equation here, and that defines the equation of the circle as we have been asked to do. So hence, we say x implies that x minus 5 over 2 squared plus y minus b, so that will be plus 3 over 2 squared is equal to radius squared, okay, which is 10.51 squared. So this is the equation of the circle. Friends, I think that's where we'll call it a quid. So now you can take your time, go through the question, and then analyze it. You see, be able to sketch the curve, knowing that ABC is a right angle, you prove. So knowing the gradient, and multiplying them together, that gives us negative 1 here. Okay, it gives us negative 1 here. So this is the proof for the first part. Okay, and after that, we calculated the distance AC using the coordinates of A and C together, and use our usual distance formula. Okay, we substituted, we subtracted, and we squared them, and we had this to be the diameter. Yeah, then we know since A, B, and C are perpendicular, it means the AC is the diameter of the circle. So knowing the distance of the value AC divided by 2, that gives us the radius. Okay, and also once again, since AC is the diameter, and we need to find the midpoint of the circle, and that will be the center of the circle. Okay, so we use this equation once again, and we digest it, and there we are. Well, until we meet us again, I will say au revoir, goodbye.